Welcome back to the morning show. It's Wednesday. That, of course, means it's time for our favorite segment, Wise Guy Wednesday. Matt Sullins joins us, and you're going to be talking about sound waves today.
Yeah, speed of sound and Doppler shifting, all kinds of stuff like that.
Ooh, Doppler.
Robert likes that word.
That's right. So the question I asked at the end of last week was, suppose I have a high-pitched sound and I compare it to a low-pitched sound, and I want to know what the distance between the waves are, the wavelength. Is the wavelength going to be smaller or bigger for a high-pitched sound? Mm-hmm. And the answer is that the wavelength gets shorter as the pitch gets higher. And Andy Ayers of Rochester, Illinois, sent me that answer, so he's getting a T-shirt.
Congratulations.
Now, right. Now, as it turns out, the speed of sound is the same. Just about, it doesn't matter what the frequency is of the sound wave. So if I talk to you low or high, then it takes the same amount of time for the sound to get from my mouth to your ear, which is good. Otherwise, it would sound kind of goofy, you have to admit, right? And so it turns out that the speed of a wave is a product of the frequency times the wavelength. So if that speed has to stay the same, like it does for sound, is 330 meters per second or about 740 miles an hour, then if one thing goes up like the frequency, then the wavelength has to go down because the product has to stay the same. Right. So I can illustrate that on this spring here. I can wiggle this spring and I get two lumps of a wave in there at this frequency. If I just wiggle it at half the frequency, then I just get one lump. So here the wavelength is long, the frequency is low. Here,
but if it was sound, it would be traveling the same distance.
That's right. That's right. And when I go faster, then the wavelength gets shorter. Okay.
Can we talk on those later?
We can talk on these. It sounds really funny. You guys can have a little conversation if you want.
We're both listening.
Now,
which is why we're not PhDs.
Yeah, exactly.
Now, the interesting thing about sound is that it travels at different speeds through different materials.
Right.
So it travels at about 330 meters per second through air, but through helium, for example, it travels almost 3 times faster, over 900 meters per second. So we can illustrate this. Here I have this little flute or pipe or whatever it is, and I blow through it and I get that sound. I can get out my helium balloon. Everybody should keep a stock of helium balloons under the table. And I'll blow through this thing with helium, and it makes a higher sound. Is that interesting?
Simply because you're changing what the sound's traveling.
I'm changing the speed of the sound. The wavelength of the wave stays the same. That's determined by the size of this thing. So since the speed got bigger, the frequency gets higher. Okay. And it's the same thing that the way it works with your voice. And you're going to help me to illustrate this, both of you guys. So your voice box is like a flute or something. It has a certain size. Right. And the pitch of your voice is determined by the frequency and by the velocity of sound. And so if I make the velocity of sound bigger, the pitch has to go up.
So right now the pitch of my voice is kind of high. It sounds kind of interesting.
All right. So, okay.
Down. It works.
How does this work? Did that work at all? I guess that worked.
So you don't want to try this at home because
this doesn't actually have an effect on your vocal cord. It just puts the gas in your throat and changes the way the sound comes.
That's right, exactly right. And so you don't want to try this at home because the helium you get from wherever you get your balloons may not be clean, and you may, hurt yourself. But this is very clean helium, so we're okay.
This is scientific. Wow,
that's right.
Starting to get a little spacey now.
I know. Kidding. Okay, so next hour we're going to talk about, the next segment we're going to talk about what?
Doppler shifting.
Doppler shifting.
And how we change frequencies, and sonic booms, too.
And you have a pan of blue something over
Caribbean
here.
water.
Caribbean. Yeah, Robert knows all about that.
Can't go wrong with things pertaining to Doppler. We'll be right back.